So, number 3 says a warning light is made up of 2 parallel connections. So this is my circuit. And each parallel connection is made up of 3 super E red lights. So I've got 3 LEDs, 1, 2, 3. And I've got 2 parallel connections. So I've got 1 connection and another connection. Notice that I've got a resistor in the circuit. Why do I need a resistor? Tell me. To keep the current in that line of 20 milliamps. Current limiting resistors. That's why they're called current limiting resistors. They limit the amount of current. So, this is 20 milliamps here. This is 20 milliamps. Draw the circuit diagram. There it is. Supply voltage is 12 volts. These kind of lights are becoming very popular for even these pocket LED lights, right? That you have now. And so these are the kind of circuits that are built for them. 12 volts, R and R, and 3 LEDs. So find the resistor size. Let's find out how much the resistor value is, similar to what we did here. So what I did here was I wanted to calculate R, so I used Ohm's law, V over I. I have to determine the voltage at the resistor divided by 20 milliamps. So what is the voltage at this resistor? What do you think is the voltage here, for example? How much do you think is the voltage here? Let's find out. What is the voltage of a super efficient red LED? Is it 2.2? So this is 2.2. This is 2.2. And this is 2.2. You follow? And therefore, based on that, I can find out what the voltage at the resistor is. So what is the voltage at resistor? Is it 12 minus how much? Is it 3 times 2.2? So is it 6.6? Okay, total voltage is 12. You see that? It's a parallel circuit. In a parallel circuit, the voltages are the same in each branch. So what's 12 minus 6.6? 5.4. So if I was to build a circuit like this in the lab, I would read 5.4 volts right there. So therefore, R is equal to V over I, 5.4 over how much? 20 milliamps. What do you get? So this is 270. What do you think is the resistance here? 270. What do you think is the current here? This is I supply. How much? What do you think is I supply? Do you see how it's split up into 2 currents? 20 and 20? So what do you think is the current? 20 plus 20, 40 milliamps. So the supply has to provide 40 milliamps of current. It's going to split up into one current here and the other current there. Okay, so you can do number 2 and you can do number 4 for exercise. Okay, it's very similar to number 1 and number 3. Let's look at Appendix 3. Appendix 3 shows an LED driver. We use the word driver in electronics a lot. What is a driver? A driver is basically an electronic circuit that adjusts the voltage and the current for your load. So in my case, the load happens to be LEDs here, okay? Bunch of LEDs, let's say. So in this circuit, what is the driver? Is it the R value? Okay? But with modern electronics, we have, for example, traffic light. You go along Simcoe or you go along Conlin, you go anywhere, you see LEDs used in the red, the yellow, and the green. Okay? Those lights have a little circuit board. And the circuit board has some electronics on it. And the kind of electronics it has are chips like this, an LM3409, for example. Okay? And this LM3409 is a chip that will be used with, for example, the red light. And you'll have another LM3409 for a yellow. And you'll have another LM3409 circuit for a green. Okay? And all of those would then have another Arduino kind of a circuit for doing the timing. 20 seconds, 5 seconds, 15 seconds. So that's what this circuit shows. It's a driver circuit for the LEDs that are shown on the right side. Okay? So you've got a 3409, you've got a bunch of resistors, capacitors, a Zener diode, and that makes up the circuit to operate an LED, a string of LED lights. And then this in turn is connected to an Arduino kind of a circuit, a microcontroller.